In this video, we are going to learn about L'Hopital's rule. Before we go through deeper on the L'Hopital's rule, let's go through the definition of limit. Let's say we have a function of x and given on a point at x equals to x naught, we have the point at y is equals to L. So given this is our x-axis and this is our y-axis. So as this function getting close to x naught, we can see that our function approach the limit of L, okay, as x approaching to x naught. Okay, and we can write it as the limit of f of x as x approaching to x naught is equals to L. So that is the limit. Okay, now let's say we have this example, given that the function is x squared plus x minus 6. So if we try to plot this, so it will be something like this graph. Okay, and we want to see the limit of x squared plus x minus 6 as x approaching to 3. So to do that, we can just substitute our 3 into x. So you will get 3 squared plus 3 minus 6, which is 9 plus 3 minus 6, which is equals to 6, meaning that the limit of this function as x approaching to 3 is equals to 6. Okay, so 6 here is the value of y. Okay, so that is the example if it involves polynomial function. Okay, so given that we have this fraction, okay, and we want to know the limit of f of x over g of x. So from the theorem of limits, we know that the limit of f of x over g of x is also equivalent to, so we find the limit of f of x as x approaching to c over the limit of g of x over as x approaching to c, where the condition must be the limit of g of x as x approaching to c is not equals to 0. So now we want to solve this limit, given that this is in terms of fraction. So what we can do is, we can see here the limit when we substitute our 4, or before that, we just separate this into the limit of x squared minus 16 as x approaching 4 divided by the limit of x minus 4 as x approaching to 4. So when we substitute this, it will become 4 squared minus 16 over 4 minus 4, which is equals to 0 over 0. So it is in indeterminate form. Indeterminate form. Okay, where indeterminate form is the form of 0 over 0. Okay, so we cannot solve this 0 over 0 where there is no value or there is no solution for 0 over 0. So what we can do is that instead of just substitute x into this function, what we can see here in the numerator is our x squared minus 16 can be simplified, where we can write it as the limit of x minus 4x plus 4 divided by x minus 4 as x approaching to 4. So we can cancel this out. Then now we can substitute our x equals to 4 into the function, where we get 4 plus 4, which is equals to 8. So the answer for this question is equals to 8. Now let's see another example. Given the limit of 4x squared minus 5x over 1 minus 3x squared as x approaching to infinity. So this is the cases to find the limit as x approaching to infinity. So if we substitute into this, you will get infinity over infinity. So this is also in the indeterminate form. And then what we can do here is we also can solve this by divide all the terms, okay, in the numerator and the denominator with the highest power, okay, with the highest power in the denominator. So the highest power of x in denominator is our 3x squared. Okay, so we just omit the 3. So the highest power in the denominator, we can see here it is x squared. Because this one is x naught, so the highest power would be x squared. So what we can do is we can divide all the terms with x squared. So now we can do is 4x squared divide with x squared minus with 5x divide by x squared over 1 over x squared minus with 3x squared over x squared as x approaching infinity. So now solving this, you will get the limit of 4 minus with 5 over x over 1 over x squared minus 3 as x approaching infinity. So if we substitute this, 4 minus 5 over infinity over 1 over infinity minus 3. So remember, any value that is divided by infinity will be equals to 0. Okay, I just repeat again. Okay, I just want to correct what I said just now. Okay, so the limit of any number divided by infinity would be equals to 0. So here I will still write the limit of x approaching to infinity. Okay, so the limit of 5 over infinity would be equals to 0. 1 over infinity is equals to 0. So our answer would be negative 4 over 3. So this will be the limit for this function, which is equals to negative 4 over 3. Meaning that our y value is equals to negative 4 over 3. Okay, so that's how we solve this kind of problem. Okay, next, what about these following limits? Okay, given that the limit of sine x over x as x approaching to 0, so if we substitute x equals to 0 into this, you will get sine 0, which is 0 over 0. Okay, same goes for this case, limit of e to the power of x, okay, meaning that e to the power of infinity over infinity. Okay, so e to the power of infinity is equals to infinity over infinity, where both cases here is in determinate form. Where we can, if we divide, okay, for the second case here, if we divide with the highest power of x, okay, in the denominator, we still get the original equation. Okay, same goes for this one. Okay, and also we cannot simplify the equation. Okay, what we can do here is, if we consider the two forms of f of x over g of x, okay, given that it is in terms of 0 over 0 and infinity over infinity, the limit theorem does not apply. So what we can do, if the limit, okay, the limit, if they exist, it can be found by using L'Hopital's rule. So this is where we need to apply the L'Hopital's rule. So what is L'Hopital's rule? Okay, so if f of x over g of x has improper form, which is 0 over 0 or infinity over infinity, then the limit of f of x over g of x as x approaching c would be equals to the limit of f prime x, meaning that we have to find the derivative of f, okay, over find the derivative of g of Okay, provided that the limit exists or limit is equals to infinity. Meaning that for L'Hopital's rule, if you found the improper form, okay, 0 over 0 or infinity over infinity, what we can do is we find the derivative of the numerator and also find the derivative of the denominator. Okay, now let's try this example. Okay, find this limit. Given that x is approaching 4. So if we substitute x approaching 4, x equals to 4 into this limit, you will get 8 minus with 2 times 4 over 4 square minus 4 minus 12, which is equals to 0 over 0. So you can either, for this problem, you can also do the factorization. But I'm going to show you another way where we can apply the L'Hopital's rule. So applying the L'Hopital's rule, we can write like this. Okay, where this means that we apply the L'Hopital's rule. LH represent the L'Hopital's rule. Okay, so now that we want to apply the L'Hopital's rule, so this limit becomes, we have to find the derivative of 8 minus 2x. So so the derivative of 8 minus 2x with respect to x would be negative 2. Okay, and then the derivative of x squared minus x minus 12 would be 2x minus 1. So the x approaching 4. Okay, now we try to substitute into the equation. So we get 2 times 4 minus 1. And you will get the value which is negative 2 over 8 minus 1, which is 7. So this is our answer for this problem. Okay, next is the previous example. So given that sin x over x will get 0 over 0. So what we can do is we apply the L'Hopital's rule, where the L'Hopital's rule becomes the limit of x approaching 0. So we find the derivative of sin x, where you will get cos of x over, so the derivative of x would be equals to 1. Okay, now we can just substitute x approaching to 0 into this. So you get cos 0, which is equals to 1. Okay, now you can try out this. You can pause this video and try out this example. Okay, now given that this is in the form of infinity over infinity, so what we can do is we apply the L'Hopital's rule. So when we differentiate ln x, it will be 1 over x. And then when we differentiate x squared, it will be 2x as x approaching infinity. So I just rewrite this 1 over x divided by 2x. This is equals to 1 over x times with 1 over 2x, which is equals to 1 over 2x squared. So here our limit is become 1 over 2x squared. So given that here 1 over infinity, 2 times with a very large number is also becomes a very large number, which is infinity. So 1 over infinity would be equals to 0. Okay, now I try the last example where this one would produce infinity over infinity. So I will apply the L'Hopital's rule, given that when we solve this, it will become e to the power of x over 2x as x approaching infinity. And you can see that the result is still infinity over infinity. So what we can do is we still apply the L'Hopital's rule, where now it becomes e to the power of x over 2 as x approaching infinity. So e to the power of infinity would be infinity divided by 2. So a very large number divided by 2, where we also get infinity. Okay. So that's how we solve this problem. You may wonder, how can I relate the L'Hopital's rule with the improper integral? Okay, let's say we have this problem, 1 plus 3x e to the power of minus x dx. So given that the limit is from 0 up to infinity, so since one of the limit is infinity, so this is a case of improper integral where we have to change this in the form of limit of 0 up to t, given that t is approaching infinity, for 1 plus 3x e to the power of minus x dx. So here, this is the case of two product of function. So first, I solve the integration, okay, without the limit. Okay, so I just solve this 1 plus 3x e to the power of minus x using the tabular method. Okay, and I got this result, meaning that this is the result from the integration. Okay, then the next one, okay, once I have solved the integration, okay, I just substitute back into the limits. Okay, and this is the result from the tabular method. Okay, the next part is that I substitute t and 0 into this equation, and I got the form of this one. Okay, the limit of t approaching infinity, negative 1 plus 3t e to the power of negative t minus 3 e minus t plus with 4. Okay, so here I got this plus 4. Okay, now you can see at this part here, okay, where this is the limit of t approaching infinity. So I solve this separately. So where we have three parts, the first part is this one, the second part is this, and the third part is this one. Okay, so here for negative 1 plus 3t over e to the power of t, when you substitute with t approaching to infinity, you will get infinity over infinity. So this is where you apply the L'Hopital's rule. Okay, so you apply the L'Hopital's rule and you will get negative 3 over e to the power of t. But the rest is you don't have to apply the L'Hopital's rule because you straight away got the value for this one, 3 over infinity, which is equals to 0. Okay, and the last one is also plus limit of this one I should write limit of t approaching infinity equal 4. So the answer would be just 4. Okay, so here this is the part that I want to show you where we can apply the L'Hopital's rule in the improper integral. Okay, because why improper integral? Because it involves limit. Remember, if the case is in improper integral, you have to change to the limit first. Okay, then solve the integration. Okay, and the rest is the same like the normal integral. However, the different case here is just the limit. You have to write the limit. Okay, so now we can solve the first part here where we get negative 3 over infinity, which is equals to 0. So your final answer would be equals to 4. And you can pause this video and try out this by yourself. Okay, and make sure that at the end you should get the same answer like mine. Okay, so that's all for the L'Hopital's rule.